from university, Master of Electrical College in this university. First, I'm going to talk about the automated electrical board, modern board of microcomputers and electronic control devices, which are operated based on electricity. What is the use or we have electrical disturbances? As you can see in the first preparation of this event, we are guys looking for the lighting and they want to power it off or turn on or turn off. What will happen is in this event we just lost electricity. All the preparation that just goes wrong. And have you ever thought about what happens if the power plants electricity supplier goes off just for a second, and the manufacturer or manufacturer industry just lose the power electricity for just 1 second? Have you ever imagined what happened? And simply at work, I'm sure that you have experience about what happened in your work when you what happened in your work if you experience the electricity disruption when you are doing by a computer and missing unsafe data, which is a disaster for everyone at work. So if you can just think about it more in depth, you can see that how much our life nowadays relate to electricity. That's why the term of power quality becomes one of the most prolific buzzwords in power industry since 1980s. So, and it is an umbrella conception for a multitude of industrial type of power system disturbances. According to this notability of electricity, the need for a clean power system has never been so great. Now I will just move on to explain the power quality definition in some points of view. There can be completely various definitions for power quality. Academically speaking, power quality is the study of voltage and current sine waves that apply to our systems or premises distributions on wiring or our building as well. What we are expected from the sine waves is to be nice and smooth and clean and perfect sine waves, which is applied to our electrical equipment without any disturbances such as notches, jag, or unwanted current at frequency, unwanted currents flowing to our systems,
at frequency other than 50 or 60 hertz, that we call it harmonics, which cause neutral overheat or burnout transformer or electrical motors, which can be a disaster for industrial situation. A utility may define power quality as a reliability and show statistics demonstrating and its system is reliable and the system is reliable 99.98%. Criteria established by regulatory agencies are usually in this range. And even a manufacturer of load equipment may define power quality as those characteristics of the power supply that enable the equipment work properly. Last but not least, for all of us as domestic users of electricity, we are expected the electricity pure electricity and perfect and apply to our home appliances and sensitive electronic devices that we have. This can lead us to the concept of poor power quality and its consequences. The effects of poor power quality is, which is, I'm sure all of you are familiar with it. One of the most important of them is computer lockouts, flickering of lights or computer screen, and breaking production, overheated neutral, overloading, and noise and stripping. Now I'd like to draw your attention to genesis of poor power quality. These are many factors affect the quality of the power. And here I just wanted to describe the most common issues. One of the most common factors is voltage surge, and that's referred to as an overvoltage or a line swell. It is temporary voltage level increase for duration from a cycle and from a half cycle to a few seconds. Often it's caused by large load shutdowns, such as switching of high power electric motors, and also because externally as loads are shed from the utility. The other factor is power interruption, which is caused by complete use of voltage for an extended time period. Burnouts, the supply voltage level has been restricted. And the solution, which due to that effect, would be uninterruptible power supply UPS. We can use UPS, power conditioner, and voltage regulation, and even generators. So, why we are concerned about power quality? According to what I said earlier, I'd like to conclude it by saying that the ultimate reason that we're concerned about is the economic value due to poor power quality, which can have a direct economic impact on many industrial consumers and domestic users as well. There's a big money associated with these disturbances and its effects. A big money associated with the disturbances. It is not uncommon for a single or commonplace and momentary utility breaker operation to result in $10,000 loss to an average-sized industrial concern by shutting down a production line that requires 4 hours to restart. And I'm going to thank for your attention, listening to me, and I would like to answer your any question. Yeah.
On the solution slide, one of them is
Solution slide, sorry.
Yeah, the solution slide. One of the options you had there was a power conditioner. What is that?
Power conditioner. It's devices that can apply to power line, which is try to smooth, which can apply to our that I said about the voltage sine wave. It can smooth and clean the voltage which is occurred by notches or jag or currents. That's all I think. Another question?
With the domestic power supply that's being generated on the rooftops of houses, how good is that power that is fed back onto the grid?
Yeah, that's the most important thing. If we grounding, yeah, it's very important in power supply generation and distribution, and to have this mitigation of power disturbances. One of the I think ultimate solution to reduction the disturbances in home appliances, power supply which is applied to home appliances, is to use grid and grounding and wiring that is really effective for that.
You're talking here a lot about solutions for power lines that are already, in low quality. I'd be curious, what are the causes for the quality to drop? Why do you have harmonics? Why do you have out of phase current and voltage? Why do you have swells? Yes. What are the causes for deterioration of power quality?
Yeah. As I said here, I can mention you here about the harmonics. I told you, when we have voltage and current sine waves as a perfect, when the currents, unwanted currents flow to our systems at frequency other than 50 or 60 hertz, which is our appropriate frequency. If we don't have this frequency, we face to harmonics, which can cause burnout motors and transformer. Yeah, that's it. The frequency is more important for this one.
Thank you.
So, you touched briefly on the issue of balancing phases and the consumption for different. Well, I'm aware consumption for different phases is an issue. I just want to capture a bit more from the question I was asking before about the solar panels on roofs. Does that affect the phase balancing, or how does that affect as well the harmonics of a new source on the system, which is essentially going to have its own phase? Well, it'll be supplying to one phase by itself, but also going to be out of phase with that one that it's supplying to.
Yeah, that's an issue that I'm just looking for the prepare research for that, because I'm among the research for this kind of solutions, and I can just refer you to the original websites or the original books that can refer to this solution.
Okay, I think it's just about 5 minutes for questions, so can we please thank our presenter once more?